zero order only. Okay, why? Because it is called a zero order, you know. The reaction here, when you are placing H2 and chlorine gases over a water, is the rate of reaction studied by nothing. The rate which the water rises, the vessels due to dissociation with the as the chlorine. The rate rise of water is the same rate disappearance of H2 and other Cl. And this equation in the presence of water, when we are consider the amount of this particular HCl and as well as the H2Cl2 is not a changes. There is a totally the concentration is the same in the presence of a water. That is why whatever the amount of water is increases, that amount of a production of HCl is also increases. Okay, that there is no concentration change. Na? The concentration nothing but you know very. In the sixth lesson you have already. Yes, the solute and as well as the solvent. Okay, clear or not? The solute amount is increases, solvent amount is also increases in the same ratio. At that time, concentration is a constant or not? Any change in the concentration? You know, I thought it is there is somewhat 200 ml of water you consider, and as well as the 20 ml of HCl you consider. This is a 10% of dilution. You know very. Got it or not? And suppose I am taking 40 ml and as well as 400 ml. What is the change coming here? Not a changes are coming now. Concentration is a not changes. The changes of concentration is zero. That equation is called zeroth order. Understand not all of. That is only about the zeroth order equations. And in the last class we have discussed. And next one, decomposition of nitrous oxide on a hard platinum surface. That is also give the zeroth order only. Okay, clear or not? Yes. And these are the things whatever there that simply he takes the change of any particular reaction order is zero. That is called zeroth order. In case it is a 1, it is the first order. In case it is a 2, second order. Like that we can. Okay, clearer? Yes. And the next component is the decomposition of NH3 presence of the molybdenum or a tungsten. Okay, now yes. These all are also called a zeroth order only. Is decomposition of nickel on the gold surface indicates addition of acetone in the presence of H plus ions. These all are contained about zeroth order only. Okay, the concentration is not changes with the time. Okay, now during the reaction also the concentration is not changes with the time. If change the concentration, the product is also getting the same ratio. That is why that is called the zeroth order. Understand not all of you. This is about orders of our reactions. Got it? Next you come for okay. What is the characteristics of a zeroth order? What is the characteristics of the zeroth order? The concentration of the reactant decreases linearly with the time. Understood not all of you? Understood or not? The concentration of the any particular reactant is a changes linearly with the time. Okay, now yes, concentration is a changes with the time. It is also that whatever concentration is there, it is a changes with the time. That is why that is a proportionally based, but totally overall resultant to become zero changes in a concentration order. Okay, that is only we are considering. The concentration never changes here. Okay, now it is a linear changes with the time. Okay, now yes, like a uniform motion in a physics. Okay, got it or no? Yes, next one. That is only the equation part here written as a to the power of t to the power of 0 minus okay, clear or not? This is only the nature of the yes, our zeroth order. Okay, and next one here. What you consider next component, the time required for the reaction to be complete, that is the time at which the concentration of A is 0. Okay, clear or not? Whatever the time required for the reaction to be complete, okay, that will be become what the ratio of the initial concentration to the rate constant. Okay, clear or not? The time is equal to taken as the what? The time whatever complete the reaction is taken as yes, what is this? Concentration at the what the time zeroth order by what? By rate constant K. Okay, clear or not? This is only give the time for us. Okay, clear or not? For a completion of total reaction. Okay, in the zeroth order it is changes for order to order, the time completion. This formula is also important. And next one, okay, now whatever the units for the K are, okay, in this particular time, you know very well. What is the units for the zeroth order? Okay, now, yes, the whatever K value, you know very well, K is equal to taken as a what? A concentration of by A. A to the power of what here? Okay, the concentration is taken as a what? A mole per liter to the power of what it is second. You know very well all this. Okay, now already we completed this problem. And after that, the concentration for it is taken as a mole to the power of liter to the power of 0 it is. Okay, clear or not all the students? Automatically there is nothing it is. Something power 0 is become 1. You know very well. And automatically it is become what here? Mole, yes, by liter by second. Got it or not? By liter by the second. Now it also it has mole liter to the power of -1 and second to the power of -1. This is only the yes, whatever the constant our rate constant okay now yes units. These are very very important here. Understood all of you? First thing is about the zeroth order. There is a zeroth order rate law. It looks like R is equal to K into A to the power of 0. Okay, clear or not? Second thing is a what? And here what we are considering, no, there is a concentration of the reactant is a decreases linearly with the time. Okay, clear or not? Yes, linearly with the time. And for completion of the time constant purpose, for the completion of the time of a zeroth order is depending on the rate constant and it's the initial concentration. The initial concentration is taken as A to the power of 0. Yes, the rate constant is a K. Clear or not? The K rate constant units are written in the zeroth order like this. Got it or not? Yeah, please note down point by point here for a zeroth order. Zero order reaction purpose. Zero order reaction, characteristics of zero order reaction. It's important for you for the solving the problems. Okay, the example, whatever there. First write down zero order reaction. This one is only enough. The remaining don't concentrate. It is not a problem for us. Why? Because that much of depth is not important. You have to know what is the zeroth order first. Write down the zero order. Zero order. Please note down that all the students these points. And what difficulty it is. Okay, now yes, whatever necessary things are there, that is only please note down from this particular topic. Zero order. Already we completed about molecularity. That is the having textbook. I thought you complete the notes. I hope you are completed the notes of molecularity, different molecularity and order of reaction. Yes. Now write down zero order reaction. A reaction said to be zero order. A reaction said to be zero order. A reaction said to be zero order. If it's a rate, if it's a rate is independent of, if it's a rate is independent of, is independent of the concentration of the reactant, is independent of the concentration of the reactant, concentration of the reactants, concentration of the reactant. Rate is proportional to the zeroth power of zeroth power of zeroth power of the concentrations, zeroth power of the concentrations, zeroth power of the concentration of the reactant, zeroth power of the concentration of the reactant. Got it? Zeroth power of the concentration of the reactant. Yes, that is R is equal to K over 0. Okay, which implies R is equal to K. A to the power of 0 is equal to 1. Got it? R is equal to K. Next one, characteristics of the zero order reaction. Characteristics. Characteristics. Simply write down the characteristics. Yes. Reacting between linear. Okay. Concentration of the reactant decrease. Concentration of the reactant decrease is the time. It is the component of the time. Time at a to the power of 0 is equal to time for a to the power of 0 is equal to a to the power of 0 by k. A to the power of 0 by k. Next, one more point. Units for rate constant k. Unit for the rate constant k is equal to mole e to the power of second to the power of. These are the important things to note down for a zeroth order. Remaining examples and everything is the content in your textbook. These are only the applied for purpose and other solutions purpose. Yeah, the table that is given last the page number 27. Once take it here, whatever the given here in the table. Okay, don't go with all the things whatever given in our textbook. May not you get it, right? Because it is above your order. Okay, just to simply what they given. Okay, now yes, what is the order nature? Okay, one thing because of this, whatever the given things are there in our textbook, something it is above your knowledge order. Okay, that is why minimize that whatever the things are there. The minimization thing is also given in your textbook in the page number 27. Once check it. One tabular format is there. In the tabular format, whatever the things are there, that is you are kept in your mind. It is enough to solve the reaction rate purpose. Okay, clear or not? Yes, what is the values they given? That is enough. And as well as somewhat a half-life also. Half-life time. What is that? Now we are going to discuss the first order then. Next, what is the first order? The concentration is a one for a one particular reactant. It is only called what? First order. Understood not all the students? The reaction, whatever there, okay, clear or not all the students? First order. First order purpose. How we written order? Yes, any particular product reactant is there. It is a produce the product. Okay, now yes, the concentration of a one only. Okay, that is only called what? A first order reaction. Okay, now which is the called a first order? A reaction said to be first order if its the rate is determined the change by the one concentration term only. Only one concentration term it is there. It is only called what? A first order reaction. Okay, got it or not? There is only what is the concentration. The rate law is written for it is a Ka to the power of 1. This is the first thing. First, you have to know what is the rate law for it. Okay, got it or not? Yes, simply we take it is the concentration is as a 1. That reactant is only called the what? Rate of first order rate. Okay, now first order reaction. Got it or not? Yes, the concentration in a reactant or a rate law, it is a 1. It is a one term only, not a two terms, not the three terms. It is a called a what? A first order reaction. Got it or not? Zeroth order is nothing but it is not depending on the concentration. It is depending on other factors. Sir, then how it is a called a reaction? Yeah, there is a concentration is not main role played here. The time, okay, the temperature, they are played role here. Just we are taken one substance, we will not change the concentration. It is a produces the products. But here the concentration is also main role played here. Okay, now that it should be now one term, one reactant term is should involved in the chemical reaction. Okay, clear or not? That is only called a first order. Yes, there is a, when you check it here, whatever the rate reactant it is there, na? How to find out the rate reactant for it is. Okay, na? Rate law is this one, and as well as the rate constant. The rate constant expression for rate constant expression for rate constant that is K is equal to 2.303 by T log A to the power of 0 by A. What is this all the things actually? The rate constant for a first order. How do we find out the rate constant? You have to use this is the 2.303 by T log. Here we consider log base 10 it is. Okay, clear or not on this? Log base we are consider here. And as well as what is the A naught here? You know very well. Initial concentration. Okay, now it is about a first concentration, first order change concentration. That is give the what? A K value for us. Okay, when you know the K, when you know the concentration, we get the R value, rate value. Okay, now when you get the rate value, then we'll get that easy information about the total reactant, how it is the changes into the products. Why these all the things are required, you know? We don't know what is going on practically when we are taken a reactant. Okay, clear or not? What is going on inside? It is not a get for us. How much time it will be taken? We not get for us. The theoretical purpose, we require this all the formulas. Got it or no? I hope you got it here. Next, after this, we have half-life period. Which one is called half-life period here? What is the characteristics mainly we are considering here? Yes, for the characteristics purpose, what we are taking already K value we are considered, and the concentration based whatever the things we are considered, and the next what we are considered the half life. How to find out the half life? Half life. Okay. Yes. And means what? Half life means what actually? The half life means what? The change of concentration. Yes, become a half of a reactant. The concentration, whatever there, 1 mole of a concentration we are considering now, that become half. Okay, that time taken for a completion of a half reaction, that is only called as a half time. Okay, clear? That half time purpose also that is directly written as the T half is equal to taken as 0. Okay, 693 by K. 693 by K. Already we have the K value. When you know the K value, you'll get the one how much time taken for a completion of a one particular reaction, half of a completion of a particular reaction. That is only we are considered like this. Understood all of you? Please note on this all the three components for a first order purpose. Next one is second order. Listen all the things, all the students, there is a second order, which is called a second order reaction. Okay, there is a word either you take 2A is the product. Okay, and here take A plus B is the product. These are two are general form of the second order reaction. Got it or not? Yes, which is become the second order. The same molecular we are taken at twice. Okay, na? Or any two terms are contained with the single concentration only, two terms are contained. Or only one term with the contained double concentration. Okay, na? That is only called the what second order reaction. Got it or not? Yes, I hope you got it here. There is a is the reactant. We have taken a 2 times of this reactant. It is a called as what? Second order reaction. Okay, not like that. Suppose not required, there is only singular substance. We have taken a 2 substances. One is the A, another one is the B. We have considered. Suppose you take a 2 components here. One is the equation. In this equation, one reactant is A, another reactant is a B. Okay, now these are the 2 reactants are there. Okay, now that will be called as, that is called as, yes, what it is? Second order reaction. Got it or not? A is a B is the another reactant. The order for A is the one, B is also one. Okay, this is the called a second order reactant. Okay, you know very well. Third order means what? Either 3A or A plus B plus C. Okay, that is a become third order. And especially up to your 9th class level, there is these orders and these principles are important. That's it. How we get these principles is not important for us. Okay, clear or not? Why? Because it is depending again on integration formulas of mathematics. Okay, clear or not? If you don't know integrations now, actually we have integration in our physics and as well as in mathematics also, but till now we are not completed. That is why it is that is somewhat looks tough. Okay, clear or not? But keep in your mind as a formulas. Understood? By heart these formulas. No need to by heart up to the rate law. Okay, clear or not? Yes, but the by heart is required for the rate constant and as well as the half life of that reaction. Okay, what is the rate law for the second order reaction? You know the rate law is a become what? K a to the power of 2 or a to the power of 2 or a and as well as the b. In our textbook, they given somewhat wrong. The rate laws are 2 types. Okay, for this one, the rate law is become what? R is equal to K into A to the power of 2. Or here it is a become what? K into A and as well as the B. Got it or not? In this way, we consider the rate law. The rate law is equal to taken as. The rate law is equal to taken as S K A to the power of 2. Or rate law is equal to taken as K concentration of A and concentration of B. Okay, now yes, in this way we are consider the rate law, and whatever constant K is there, K is equal to, it is a function of time. It is also written as 1 by T. Okay, now 1 by T into 1 by S concentration of A minus concentration of A naught. Okay, clear or not? Concentration of A minus concentration of A naught. Suppose the B is also there now, sir. You have to substitute here B also. Okay, and afterwards you add it. Okay, clear or not? Only A is there, you have to take like. Got it or not? And the next one, it is also the concentrations. In case there is a common concentration may get for us. In case we are taken, it is like. Okay, now A and as well as the A naught is into B to get the concentration rate constant formula. The rate constant formula is the become K is equal to 1 by T and 1 by A minus 1 by A naught. K is equal to concentration by the concentrations. Okay, now initial concentration into B concentration. That will be gives the what? K value for us. Okay, clear or not? Yes, and as well as half life also given. Okay, now what is the half life? It is half life for the second order reaction is become here 0.5. Okay, now yes, half life period half life period half life period is equal to T half is equal to taken as, sorry, it is not a second order purpose. Half life is equal to T half is equal to taken as 0.1 by 0.5 A by S 0.5 A. Okay, it is equal to become as what half life, and it is also as 1 by K A. Okay, clearer for all the students. Only half life here. Yes, and here the A and the A is the what? Initial concentration. Yes, the initial concentration. This is A naught. Okay, clear or not? Like that also, it is possible to write. Okay, this is about the second order concentrations. Got it or not? I hope you got it. It is second order concentrations. Yes, thank you. Yeah, don't confuse and don't feel hard it is. Why? Because it is not a our regular concepts. Okay, somewhat exceeded than our whatever our textbook. Okay, it is not level of our textbook. It is apart from our textbooks. Okay, it will be contained in your intermediate first year and pure IIT components. Okay, clear. That's why please be write down the as a notes and apply. That is for our questions. Okay, yeah. Thank you.